Here, Motion Control Quick Start 16. Mainly about EtherCAT usage. From how to wire EtherCAT to how to control servo drive. Let's begin. Obviously, we need to prepare one motion controller and one set of servo drive that are with EtherCAT. Then, corresponding program software. For motion controller, we need ZDevelop. For servo drive, here, we use Panasonic. It can be seen now the controller is ZMC432. Others, one PC, two cables with shield, 124V DC power supply, etc. Okay, at first, how the controller wiring is. There are three parts in total. Number 1, main power supply. This one, 3 terminals in this power. E plus 24V, which connects to positive pole of power. Then, EG&D connects to negative pole. For FG, it connects to shield shell. Number 2, Ethernet terminal. It only needs one cable to connect them correspondingly. Number 3, servo drive and controller wiring. Also, use one cable to connect. EtherCAT interface of controller should be linked with X2A/X2B interface of servo drive. Let's see one example. Here, ZMC460 in dual bus motion controller is used. That is, it supports EtherCAT and RTX. For RTX, it needs to connect RX of controller to TX of drive. Then controllers TX and drives RX. Other devices, connect one by one. The first device is device 0, then, device 1, device 2. They are numbered in connection sequence automatically. For EtherCAT, use one cable. It can be seen, there connects one EtherCAT expansion module. Actually same connection method and number rule as drive. That is, if slot 0 connects to EIO24088. EIO24088 will become device 0. The EtherCAT interface has two terminals. EtherCAT in and EtherCAT out. For some controllers, no rule for the wiring. But for some, they cannot connect randomly. EtherCAT in must be connected to master device. EtherCAT out must be connected to slave device. In addition, when in multi-axis control, EtherCAT out of servo drive is connected to EtherCAT in of next drive. For specific wiring, please refer to drive manual. Next, let's see how to connect our controller to PC in software. Usually, there are two methods, serial port or net port. Here, we mainly see Ethernet method. For Ethernet, connect them through one cable at first and power on controller. Then open our ZDevelop, open the Connect to Controller window. It can be seen this window shows 3 connect. Ethernet, we use the second one IP. That is, correct IP must be selected. If there is no needed IP, we can scan it and select it. Here, local IP means PC IP, please observe PC IP and controller IP. Front 3 must be same, the last one must be different. Then they can communicate. When IP is selected and their IP are OK. Click Connect. In output window, it will show corresponding information. This means success. And at this time, we need to confirm whether the controller is correct again. However, sometimes their IP can't meet communication requirements. That is, they are not in one same network segment. We need to modify them. Modify controller IP or modify PC IP. If we choose first one, there are also 2 methods. Before that, we need to know controller IP through serial port connection. Then, through window or command. When the IP changes, it takes effect all the time. If we want to change PC IP, open Network and Sharing Center. Find Internet. Click Properties. Then open this one, select second one. Now, we can fill in new IP. IP is changed after OK. Next, do connection again. Follow above steps, usually no problem for connection. After wiring and connection, it is time to set parameters. First one, communication period. It must be consistent with controller's cycle. Generally, no need to set controller communication period, because they will match automatically. There are several options. 250us, 500us, 1 millisecond, 2 milliseconds, 4 milliseconds. The servo drive period smaller, the position controlled more precise, and the response speed faster. if the communication fails, which means their communication period is not consistent. At this time, we need to upgrade controller firmware to modify controller period. Or we can check the controller period at first. The default is 1 millisecond, it can be read through servo period command. Second one, drive PDO setting. PDO means process data object. It is used to interact master station data with slave station data in periodically in EtherCAT network. Or it can be seen as one array. Each array element saves different functional codes. Then in one period, execute operations that correspond to functional codes. These codes are called data dictionary, which is presented by 4-digit hexadecimal. Please refer to below form. Each data dictionary includes subdictionary, function, data range, data type, read or write, etc. RW means it can be read and written. RO means it only can be read. Here, PDO, actually there are two PDO modes. One is RX PDO, transfer data to slave station from master station. Another is TX PDO, then it is to transfer data to master station. For example, 6040H control word. It is used to control enable, on, off, alarm, reset of servo access. Each dictionary includes 32 sub-dictionaries. For its no and initial value are checked through drive manual. And no and functions are determined by protocol. All standard EtherCAT devices use one same set of data dictionary. We only need to set bit of data dictionary. Okay, we have known PDO principle. Next, let's enter PDO configuration. In EtherCAT initialization, drive PDO configuration must be done. For this, our Zmotion provides drive profile command to set it. If we don't want to configure other modes, that is, use default PDO list of drive, please set it as -1. If we need to use new modes, there are more than 20 options. And options contains different data dictionaries. Please refer to this command in details. Like, mode 0, it has these 5. If all these still can't meet the requirement, please use SDO related commands to operate dictionary to set required PDO. SDO commands includes these 4. And these 2 are for reading data dictionary. These 2 are for writing. Actually their usage are basically same. SDO read, 6 parameters are needed. Slot no, for EtherCAT, it is 0. Device number, the number connected on EtherCAT. And it is numbered automatically. Data dictionary number, which is to be operated. Its sub-dictionary. Data type. Storage position. Data is saved into table by default. Here, we need to specify the exact position. Then, this one. The difference is here. This one is determined by access number, not device number and slot number. For writing 2, parameters are same. Third one, how to set servo drive parameters. There are 2 ways. One is in drive software, one is to use SDO command. Let's see first one method. Connect PC and drive through USB or WLAN. Here, we use USB. Connect them correspondingly. Then power on drive. Open drive software panoterm. This window will pop up. And we need to select this one, through USB. Now, drive information will be shown. At this time, communication is successful. It is time to configure parameters. Then, click Display Object Editor. It can be seen there are many dictionaries. We take the number starting from 6000 as the example. Modify 6091 and 6092 values. It only needs to double-click corresponding setting value. And in here, we can switch it as binary, decimal, and Hushy system. After modification, we need to save it. Click EP. Then, parameters will take effect after power on again. See one example. Modify the units. Units means pulse amount. How many pulses sent in one revolution? And behind parameters all take units as the basic unit. Here, 6091 is to set electronic gear ratio. 01H is to set molecular. 02H is to set denominator. 6092 is to set how many pulses in one revolution. Now, it is 10,000. After setting, move, 2, will mean sending 20,000 pulses to motor. Then motor moves 2 rounds. Next, see the second method. Use SDO commands. As we have learned just now, use SDO write command. Also set these three. Then, subdictionary, 01H. 7 is the data type. This one means write 1 for 01 of 6091. Then behind 2 are the same. After executed, values are modified. Then click EP to save. And please check whether values are correct. It shows values before and after modification. Then, click OK. Now, power off the drive and power on. Values will become new modified values. Fourth one, how to set drive I/O signals. Drive has input signals enabled by default. And they are used to protect. That is, when no external signals connected. Drive will protect an alarm. While debugging, we can close these signals through setting as 0. Still, in drive software, modify or set I/O values. Click Parameter. I/O signals are in 4. Then modify directly in Setting Value. When we need to use drive I/O, map drive I/O number at first. Then connect real signals as needed. For mapping, PDO must include data dictionary 60 FDH. If no this dictionary, mapping can't be realized. After that, use drive I/O command to set drive I/O address. Here shows the usage. It only needs access number and I/O starting number. See the example. Set the mode that is with I/O mapping. Then use drive I/O. Fifth, how to map drive access number. Before that, please note device no and drive no are numbered from 0 automatically. But for drive no, it only means drive, not others. Mapping, we use access address command. The usage is this. It needs access number, slot number, and drive number. After mapping, used base command to select drive access number. Then send pulses. Attention, access mapping is edited in initialization. Specifically, after slot scan, before bus start. And no same access number please. Okay, examples. Map drive 0 as access 6. Map drive 1 as access 7. Map drive 2 as access 8. Then, set EtherCAT bus access type for each one. There are 3 types for EtherCAT. 65 means position mode. 66 means speed mode. 67 means torque mode. Sixth, drive control mode configuration. There are 3 control modes. CSP period position mode. CSV period speed mode. CST period torque mode. Use a type command. For EtherCAT, 65, 66, 67 values. But please please confirm whether corresponding data dictionary is included. For 65, it should be with 607A. In behind routine showing, set ATYP as 65. Then, set drive profile as 1. Next, use Zmotion command to control. For 66, it should be with 60 FFH. In behind routine showing, set ATYP as 66, and set drive profile as 22. Now, use DAC command to run its speed of set value. Other units parameters don't work. Please note it has 2 units, pulses/s or rounds/min. Which is determined by drive. For 67, it should be with 6071H. Like, set drive profile as 30. It also uses DAC command, but it runs a torque value that relates to set value. For example, when DAC is 10. Now, motor torque will be 1% 6071H value. Then DAC 1000 means 100% torque because the range of DAC is 0 to 1000. Obviously, CSV mode and CST mode use DAC. If we want to switch them, please set DAC as 0, then modify a type. In this process, we can set a small value at first. Then increase it slowly according to exact situation. If there is something happen, click emergency stop or send DAC equals 0 to stop the motor immediately. In a short, set correct A type at first. Then set corresponding control mode. Next use command or DAC to control. All these, they must be corresponding. Seventh, how to check and process drive alarm. There are 3 methods. Check LED. If there is error, corresponding LED will be on. An error code will be shown. Then see drive manual to solve it. Check alarm window in drive software. Or check history alarms. In history alarms, problem and solution are shown. Generally, in initialization, use drive clear to clear error. One command is for one error. So when there are several errors, please call several commands. Or use one for loop. It only needs one mode parameter. Mode, there are 3 modes. 0 means clear current alarm. 1 means clear history alarm. 2 means clear external alarm. 8th, drive homing. For EtherCAT homing, it can use homing mode provided by controller. Mode value, please check datum command in ZBasic. Except, it can also use homing mode of drive itself. That is, don't use controller and corresponding controller mode. Here, the drive homing mode usage. The first parameter is 21. The second parameter is mode 2. It needs to check data dictionary in drive manual. For example, 6098. It can be seen there are many homing mode values. We can fill in any one value. Then it returns to origin according to corresponding mode. If we fill in 0, the default mode. Now origin position limit signal and others must be connected on drive. Which means it needs to map I/O on drive while drive homing in 0. Next, let's see one routine. Generally, run drive homing after initialization. Base means axis or axes. Also homing one by one. If there are several axes, use 4 to homing each one. Then, homing speed, reverse speed, and homing acceleration. The most important, use datum command. Here, we use mode 2. Now, drive will home according to mode 2. Before homing, we need to do initialization. It can be seen it is very important. In addition, when initialized, then it can set axis parameters and commands to control servo motor motion. Let's see how to initialize. At first, do wiring correctly, and power on EtherCAT servo drive and controller. Then connect to controller through ZDevelop. Next, initialization starts. Please see this graphic. Clear current settings. Use slot scan to scan the bus. When bus is scanned successfully, it is time to map axis number of EtherCAT drive. Also, map in order, one by one. After mapping, set axis type of EtherCAT axis. Then, PDO list configuration. Use controller PDO, or drive PDO, or custom PDO. Next, map in and out number. If no need in and out mapping, this step can be ignored. Now, it is time to start the bus. Clear drive errors. For some drives, use drive control word to clear. For ordinary drives, use drive clear. Then, set datum, 0, to clear controller errors. After this, enable EtherCAT axis. There are 2 enables. This one is to switch on main enable. This one is to switch on single axis enable. And before enabling, we can rotate the motor axis manually. Now, it is time to enable. After enabled, please send pulses to make it rotate. From now, the initialization is over. Let's see one initialization program. Even if there shows 4 parts, main initialization part is the most important. And others, drive I/O mapping, expansion module I/O mapping, special parameters configuration. If no need, they can be ignored. See the main one. Actually, you only need to copy it and set these 4 constant values. Others keep the same. First one, local pulse axis starting number. Second one, the number of local pulse axes. If 2 pulse axes are connected, please fill in 2. Third one, bus axis starting number. That is, which bus axis starts to map. 0 means the drive no of the first connected drive on bus is 0. Then, map drive to axis 0. Fourth one, how many nodes on bus, how many devices connected. In this routine, the default A type is 65, position mode. And set PDO list mapping is -1. Which means drive itself list is used. If you want to use other modes, except former 4 parameters, please modify these 2 also. After initialization, we can check connected device information. And there are 3 methods. Method 1, check through slot 0 node in controller status window. All information are shown clearly. Method 2, send command, *EtherCAT. It can be seen relative information also are shown. Method 3, open bus state diagnosis window. And the effect is same as method 2. Now, it is time to run the program. Make each bus axis home, configure axis parameters well. Then write commands into program, or send commands, or use manual window to run it. And this one is the captured waveform. Demand position and speed of axis 0. If we use manual, select axis 0. Then click left or right. Or enter one distance, then click move. Next, let's operate it together in ZDevelop. Copy the program in here directly. Connect to controller. Download into controller. Set MPOS and DPOS as 0. Configure parameters. Then, send motion command directly. It can be seen it is moving. And the result is correct. Open Manual and Scope window. Okay, now, EtherCAT initialization is shared. More, welcome you contact us. Have a nice day.